Hello, my name is Daniel, and today we will be going through the AMC 10A from the year 2014. So let's get started. First of all, what is 10 times this much to the negative first power? So it's basically 10 times, let's look at what this is. That would be 10 and 5 plus 2 plus 1, which is 10 under 8, which is 8 over 10, which is 4 over 5, but then we need it inversed, right? So this is basically times 5 over 4. If we multiply 50 over 4 equals 25 over 2, which is C. For the next problem, Roy's cat eats 1/3 of a can of cat food every morning and 1/4 of a can of cat food every evening. Before feeding his cat on Monday morning, Roy opened a box containing 6 cans of cat food. On what day of the week did the cat finish eating all the cat food in the box? Okay, so every day Roy's cat eats 1/3 plus 1/4, which is 3, and which is all over 12, because that's the multiple of 3 times 4, and 4 plus 3, which equals 7 over 12. So every day Roy's cat eats 7 over 12 cans of cat food, and he opened 6 cans of cat food. And so for seeing how long this will last, we should do 6, and then we should divide it by 7 over 12, right? And so if we switch this to multiplication, that would be 6 times 12 over 7. 6 times 12 is 72, right? So this would be 72 over 7, which is 10 point blah blah blah. And it says, what day of the week did the cat finish eating all the cat food in the box? And so Roy's cat started on Monday morning, right? And then it ate 7 days for that, and then it came back to Monday, which is the 8th day, and Tuesday is the 9th day, Wednesday is the 10th day, and so on Thursday it would have had like point blah 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 of a can left over, and it ate that on Thursday, right? So it finished eating on Thursday, so the answer is Thursday. It's C. Problem number 3. Bridget bakes 48 loaves of bread for her bakery. She sells half of them in the morning for $2.50 each. So she baked 48 and she sold half of them, so she sold 24, right? She sold 24 for $2.50 each. And in the afternoon, she sells 2/3 of what she has left. And because they are not fresh, she charges only half price. Okay, so if she sells 2/3, then since she has 24 left, she would sell 16, right? And half price, so it's $1.25. And in the late afternoon, she sells the remaining loaves at $1 each. So there's 8 remaining, $1 each. And so in dollars, what is her profit for the day? Okay, and each loaf costs 0.75. So 24 times 2.5 plus 16 times 1.25 plus 8 times 1. This is her net money that she raked in. And 48 loaves costs 0.75, so 48 times 0.75, this is the total cost, right? But then 0.75, as we know, is same as 3 over 4, and that makes it very easy, because 48 times 1 over 4 is 12, so this is $36. And so we need to get this and then subtract $36 from it, and there we will have our answer. And so 24 times 2.5, that would be 12 times 5, and 16 times 1.25, that would be 8 times 2.5, which would equal 4 times 5, and this is just basically 8, and this is 60, 20, if you add them all together, it's 88, so it's $80 minus $36, which equals, how much is it? $52. Therefore, the answer is E. Problem number 4. Walking down Jane Street, Ralph passed 4 houses in a row, each painted a different color. He passed the orange house before the red house, and he passed the blue house before the yellow house. The blue house was not next to the yellow house. How many orderings of the colored houses are possible? Okay, so the restrictions that we have are that the orange house has to come before the red house, and the blue house has to come before the yellow house. So there's 4 houses in a row. but the blue house was not next to the yellow house. That means there can be, so that means the orderings of the houses can be blue, yellow, or blue, yellow, like this, or blue, yellow, like this, because there is no other way for blue to be before yellow without them touching, right? And so if we have this set, then we have 2 spaces left over for all 3, but then in those spaces this restriction comes in, and that's where we can say this is the exact order that the remaining spaces will be filled. So BOYR OROR. So Boyer, Aubrey, and Bory, right? And so there will be 3 orderings of the colored house possible. The answer is B. Number 5, on an algebra quiz, 10% of the students scored 70 points, 35% scored 80 points, 30% scored 90 points, and the rest scored 100 points. What is the difference between the mean and the median score of the students' scores on this quiz? Okay, so since the median is far easier to calculate than the mean, let's just do that first. Okay, so the median is from the least to the greatest, where so it's asking where is the 50%, so where's the half mark, and what is the score corresponding to that half mark. And so if we see 10% and 35% makes 45%, so the first 45% scored 80 points, and then after that 30% scored 90 points. And so since these two make 45% and the rest of the negative 5% is added from this 30% of 90 points, then the median will be 90 points. So let's erase all this. The median would be 90 points. Actually 90%. No, 90 points. Yeah. And now let's calculate the mean. So for convenience, let's say there were 20 students in total, because that's 100 divided by 5. So if there were 20 students in total, 10% of 20 is 2, and 35% of 20 is 7, 30% of 20 is 6, and the rest, this is 100 minus 10 minus 35 minus 30, which is 25%. So 25% of 20, that is 5, and if you check, you can see that 2 plus 7 plus 6 plus 5 does equal 20. And so 2 students score 70, so that's 2 times 70. 2 times 70 plus 7 times 80, because 70 people scored 80 points, and plus 6 times 90, 6 people scored 90 points, and the rest, which is 5, scored 100. So 5 times 100, and that's all over 20, because we assumed that there were 20 people. And if we take out 1 0, if we cross out a 0 from each, 7, 8, like that, and we cross out a 2 from each, so that 2 would go away, that 2 would go away. This 8 would become a 4, this 6 would become a 3, and this 10 would become a 5, right? And so we don't need this anymore, and so this equals 7 plus 28 plus 3 times 9 is 27, plus 5 times 5, 25. This is 88. And so, no, sorry, not 88. It's 87, right? And so 90 and 87, the difference between that is 3 points, so the answer is 3. It's C. And for problem number 6, suppose that A cows give B gallons of milk in C days. At this rate, how many gallons of milk will D cows give in E days? And they forgot a question mark. So A cows give B gallons of, so A cows in C days, they give B gallons of milk, right? And so 1 cow in C days and so A cows in C days give B gallons of milk, right? MILK, right? And so then 1 cow in C days would give B over A. B over A, gallons of milk, and 1 cow in 1 day would give B over A over would give B over A times C, right? This much gallons of milk, and now this has to be D cows, so this would be B times D. I'll move milk away, and it has to be E days, right? So this is E days, and we multiply E, so it's BDE over AC. That is A. Number 7. Non-zero real numbers x, y, a, and b satisfy x is less than a and y is less than b. How many of the following inequalities must be true? Okay, so usually you would go about with like putting random numbers in here, but then just for this problem solving to be more accurate, I'll just say a equals x plus like something k, and b equals y plus like m or something, right? And so replace x by x, no, so replace a with x plus k and replace b with y plus m. That means and that gives us x plus y is less than x plus y plus k plus m, right? And so this has k plus m more, and so so this is correct. Number 2, x minus y is less than a minus b, and so this will be just putting the same things in, x minus y, and then x plus k minus y minus m, and so this all depends, and so this simplifies down to k minus m is greater than 0, but we don't know if this is true, so this cannot, no, so this may not be true, and thus we cannot say that it must be true. Number 3, xy is less than ab, and here it just said it's non-zero real, and for here it said that it's non-zero real numbers, right? And so it can be negative too, and so if x is minus 45 and a was 1, if y was negative 54 and b was 2, then this would still be okay, right? But then xy would be 45 times 54 and ab would be just 2, and so obviously this doesn't hold true for every combination, so number 3 is also wrong. And number 4, x over y is less than a over b. Let's just so let's say so the same logic applies with number 4. Let's say x equals negative 100, a equals 1, b and y equals negative 1, b equals 3000. Then this much would be saying that minus 100 over minus 1 is less than 1 over 3000, and this is definitely not true. So for number 4, we can't say that it always holds true. Therefore the answer is B, because we have only one answer that must be true. Number 8, which of the following numbers is a perfect square? Looking around at these, we see that this is 14 factorial squared times 15 over 2, and the same goes for all of these. And we can see that this is 17 factorial squared times 18 over 2, right? Because 17 factorial times 18 factorial is 17 factorial times 18, so these two group together to make this. And so it's 18 over 2, and this is 9, right? Which is 3 squared, and so this is 17 factorial squared times 3 squared, which is also a perfect square. Therefore the answer is D. Problem number 9. The two legs of a right triangle which are altitudes have length 2 root 3 and 6. How long is the third altitude of the triangle? Okay, so the right triangle will look something like this, and this part would be a right triangle, right? And so have length 2 root 3 and 6, so this is 2 root 3, this is 6, and we can immediately notice that 6 is root 3 times 2 root 3. That makes the ratio of this is 1 to root 3, and therefore this must be 2, and so the length of this must be 2 root 3 times 2, because this is 2 times this one, which equals 4 root 3. This is 4 root 3. How long is the third altitude of the triangle? Okay, so what is the third altitude of the triangle? That's this line right here, and this would be 90 degrees. and so we want to find this length. And if we see this this length multiplied by this length is equal to this length multiplied by this length, because they both represent 2 times the volume of the 2 times the area of the triangle, right? And so if we say this is x, 6 times 2 root 3 equals 4 root 3 times x. X equals 6 times 2 root 3 over 4 root 3 equals, this is 2, so it's 3. The answer is C. Problem number 10. 5 positive consecutive integers starting with a have average b. What is the average of 5 consecutive integers that start with b? Okay, so 5 positive consecutive integers starting with a, that's a plus 1, a plus 2, a plus 3, a plus 4, and their average is a plus 2. So b is a plus 2. What is the average of 5 consecutive integers that start with b? So for 5 consecutive integers that start with b, we can just replace a with b, and so that would make it b, b plus 1, b plus 2, b plus 3, b plus 4, right? And so what we want is b plus 2, but b is a plus 2. So this is a plus 2 plus 2, which is a plus 4. So that gives us b. The answer is b. Number 11. A customer who intends to purchase an appliance has 3 coupons, only one of which may be used. Coupon number 1, 10% off the listed price if it's at least $50. Coupon 2, $20 off the listed price. Coupon 3 is 18% off the listed price. No, 18% off the amount by which the listed price exceeds $100, right? So for which of the following listed prices will coupon 1 offer a greater price reduction than either coupon 2 or coupon 3? First off, we can cross off A and B, because for coupon 1 to be greater than coupon 2, then coupon 2 is $20 off, and for coupon 1 to take more off, $20 should be less than 10% of the listed price, right? And so the listed price has to be at least $200. That's why A and B are crossed off right away. And now we only have to compare coupon 1 and coupon 3. So let's go with C first and work out all the others. 10% off the listed price, so this 21.995 off, right? This is for coupon number 1. And for coupon number 3, 18% off the amount by which the listed price exceeds 100. So this is 18% times 119.95. And 119.95 multiplied by 18%, which is 18 over 100, that will be $21.5910, right? And we can right away see that 21.995 is more than 21.591, and thus C is the answer. Yeah, we got the answer right away. So the answer is C. Number 12, a regular hexagon has side length 6. Okay, so this is 6. Congruent arcs with radius 3 are drawn with the center at each of the vertices. So basically, what is the area of the shaded region? This much. And so that's basically the area of the hexagon minus, like, these 3 form 1 full circle. So 2 full circles, right? And so it's basically the area of the hexagon, which is, if you divide it like this here, it will become 6 equilateral triangles. And so this is 6 times 6 squared times root 3 over 4. This equals 6 times 9 times root 3. This is 54 root 3, and since this is 54 root 3 and we'll be subtracting like something pi values, we can immediately cross out E, B, and A because they don't include 54 root 3. And now to calculate the circles, these have radius 3, so one circle is 3 of these, so we need 2 of those 3, right? So it's 2 times 1 full circle, which is 3 squared pi, which is 18 pi. The answer is 54 root 3 minus 18 pi equals C. Number 13, equilateral triangle ABC has side length 1 and squares ABD, EBC, HIC, AFG lie outside the triangle. What is the area of hexagon DEFGHI? Okay, so first of all, what we have to see is that the area of this triangle and these three triangles, they are all the same, right? Because if you cut them like this, like this, like this, and like this, you see that all of these triangles are the same, right? And so what we just have to do is find like the area of this one equilateral triangle. It has side length 1, so this is root 3 over 4 times 1 squared, because that's the formula for an equilateral triangle, and multiplied by 4. This equals root 3. And now we need to get the area of these 3 squares. That will be 3 times 1 square, right? 3 times, and then we need a side length. ABC has side length 1, so this is 1, so therefore this whole thing must be 1 squared. So it's 3 times 1 squared equals 3 times 1 equals 3. So it's root 3 plus 3, it's C. Problem number 14. The y-intercepts P and Q of two perpendicular lines intersecting at the point A6, 8 have a sum of 0. What is the area of APQ? So if we kind of draw this, this would be the grid, and there would be the point 6, 8 right here, and then these would be the two perpendicular lines, like this, and oops. Like this, right? And so these 2 points have a sum of 0. So let's say that this is A, this is minus A, this would be minus A, right? And then this is 6, 8, right? And so what is the area of APQ? Then this for this we need to get A times 6. So we need 6A. Because this much is 2A, I'll do that in a different color. This is 2A, this is 6, so 2A times 6 times 1/2 is 6A. So the area we need to get is 6A. And what is the area? Okay, so what we need to find is A. Since the lines are perpendicular, then we can see that this slope and this slope will be the negative reciprocal, right? And so this slope will be 8 plus A over 6, because if you see here, this much is 6, this much is 8 plus A, so that will be 8 plus A over 6. And now this side would be, this much is minus 6, and this is A minus 8, right? So minus 6 and then A minus 8. So these two are negative reciprocals. If we write them again, A plus A over 6 and negative 6, negative A minus 8 over 6. And then if we flip them around, they should be negative reciprocals. Let's flip this one because it has the minus sign. That will be 6 over A minus 8, right? So these two will be equal. And then all that is left is cross multiplication. These two give us A squared minus 8 squared, which is A squared minus 64, equals 6 squared 36. A equals root 100, which is 10. The answer is 6 times 10, which is 60. The answer is D. Number 15, David drives from his home to the airport to catch a flight. He drives 35 miles in the first hour, but realizes that he will be 1 hour late if he continues at this speed. He increases speed by 50 miles per hour for the rest of the way to the airport and arrives 30 minutes early. How many miles is the airport from his home? Okay, so first he drove 35 miles, right? So that's just 35 miles that he went. And this means that he drove 35 miles per hour in the first hour. And then if he increased his speed by 50 miles per hour, that would be 50 miles per hour, right? And so let's just say that the additional distance that he had to travel was X miles. Since the time difference between going at 35 miles per hour and 50 miles per hour is 1 hour and 30 minutes, we can say that x over 35, which is the time, let me write this in a different color, time for 35 miles per hour. This would equal x over 50, which is time for 50 miles per hour. And then since the difference is 1 hour and 30 minutes, this would have to be plus 1.5 hours, right? And so because of this, if we cross multiply this entire equation, 50x equals 35x plus 1.5 times 50 times 35, right? So this is 15 times 5 times 35, and so 15x, because this moved over, 15x equals 15 times 5 times 35. So if the 15's cancel out, x equals 5 times 35. This is 175, and so 35, which was the distance that he first traveled, and then x is 175. So we have to add up these together, right? So 35 plus 175 is 210. So the answer is 210 miles. The answer is C. Number 16, in rectangle ABCD, AB is 1, BC is 2, points EFG are midpoints of BC, CD, and AD respectively. Point H is the midpoint of GE, so what is the area of the shaded region? Right here. Right, so the first thing that we want to do is put a line through HF. And that is because we have to notice that this triangle and this triangle, they are similar triangles, right? And so because they share this angle and these are parallel and stuff like that, right? And so we can see that these are similar, but since this length is 1, that means that the ratio between these two triangles is 1 to 2. So this would be 1 to 2, 1 to 2, stuff like that, right? And so this to this, those altitudes would also be 1 to 2, but then since the total is 1/2, then this would be 1/2 times 1/3, because it's 1/3 of the whole thing, right? So that would be 1/2 times 1/3. That would be 1/6. 1/6, and this length is 1, as mentioned previously. So the area of the shaded region is just 1 times 1/6. So it's 1/6. The answer is E. Number 17, 3 fair 6-sided dice are rolled. What is the probability that the value shown on 2 of the dice sum to the value shown on the remaining die? Okay, so we have 3 fair dice drawn like this. And the values on two of the dice have to sum to the value on the remaining die. Like this would be 1, this would be 2, then this one should be 3. So this plus this equals this. And for this, we can see that there are only 5 possibilities for the sum value of the die to be, and that is 2, 3, 4, 5, and 6. And so the sums can only be 2, 3, 4, 5, 6. And let's space them a little more apart because we are going to be entering multiple values into them again. 2, 3, 4, 5, and 6. And for 2, it's obvious that the only numbers possible is 1 and 1. And for 3, we can have 1, 2, and 2 and 1 is essentially the same thing as 1, 2. So it's just 1, 2 also for for 3. No, for 1, 2 for 3, and for 4 it can be 1, and for 4 it can go 1, 3, 4, or 2, 2, 4, and 3, 1, 4 is the same as 1, 3, so that will be disregarded. And 5, for 5, that will be 1, 4, or 2, 3. 3, 2 is the same as 2, 3. 4, 1 is the same as 1, 4. So it's 1, 4 or 2, 3. And lastly, for 6, it can be 1, 5, or 2, 4, or 3, 3, and 4, 2 is the same as 2, 4, 5, 1 is the same as 1, 5. And so for the sum to be 2, 1, 1, 2, and this can be changed about in 3 ways, because it can be 1, 1, 2, 1, 2, 1, 2, 1, 1. And so that would be the 3 ways. And similarly, for this would be 6 ways, because it's 3 factorial. So 1, 2, 3, and so there's 3 different numbers. That's why 3 factorial is possible. And so similarly, 1, 3, 4. Similarly, 1, 3, 4, this can go 6 ways, and 2, 2, 4, this can go 3 ways, just like 1, 1, 2. And 1, 4, and 2, 3, they are both 6, because 1, 4, 5, 2, 3, 5, they are all very different, so it's also 3 factorial. And for 6, 1, 5, 6, that would be 6, because it's 3 factorial, they're all different. 2, 4, 6 would also be 6, they're all different. 3, 3, 6, that would be the same as 1, 1, 2, so it's 3 ways. And so we have to add all of these colorful things up. So it's 3 ways plus 6 ways plus 6 plus 3 for 4, and plus 6 plus 6 for 5, plus 6 plus 6 plus 6 plus 3. And so this would be, there are 6 sixes, so 36 plus 9 equals 45. And there are 45 possible times, so that's 45 over all possible things. So 3 pairs of six-sided dice, so that's 6 to the third power, that's 216. And if we divide by 9, this will get us 5, and this will get us 24. So the answer is 5 over 24. It's D. Number 18, a square in the coordinate plane has vertices whose y-coordinates are 0, 1, 4, and 5. What is the area of the square? So this is very easily solved by just like drawing a simple coordinate plane, and y-coordinates are 0, 1, 4, and 5. So 0, 1, 2, 3, 4, and 5. And so this would mean that this square would be fashioned like something like this, right? And all these lengths would be the same, and all these triangles, if you see here, there are 4 triangles created. All these triangles would be congruent, and so for that to happen, this length and that length must be the same for this and this, for this and this, and for this and this. And so since this length is 4, this length must also be 4. Since this is 1, this must also be 1. And so since this is 4 to 1, so this length is root 4 squared plus 1 square, which is root 17. And so the area of the square, this is root 17 squared. This is 17. The answer is B. Number 19. 4 cubes with edge length 1, 2, 3, and 4 are stacked like that. What is the length of the portion of xy contained in the cube of edge length 3? Okay, so first let me make this list of cubes see-through. Okay, so that's the 4 cubes, and portion xy. So from x to y, that long line would be this line over here, and we can see that a right triangle can be formed with these red lines, right? And so from x to y, right? And so edge length are 1, 2, 3, and 4. That means this is 1, 2, 3, and 4. So the whole thing would be 10, right? So this would be 10, and this length, that would be 4, 4. So this is 4 root 2. And from the Pythagorean theorem, we can calculate this length, which is root 10 squared plus 4 root 2 squared, which equals root 100 plus 32. It's root 132. And from that, what we need is from here to here, we need this length. And if you see these 2 points, if you kind of like try and see this triangle horizontally, then this is also right, and this is also right angle. And so so the ratio of this length to this length is the same as the ratio of this length to this length, right? And so since the whole thing is 10 and this is 3, that means this length is also 3 over 10 of the whole length xy, and the whole length of xy is root 132. This is 3 over 10 times 2 root, and then we have to divide 4 from 132. That will be 33. This is all over 5, 3 root 33, and so the answer is A. Number 20, the product 8 times 8, 8, 8, 8, 8, 8, 8, 8, all the way to 8, where the second factor has k digits, is an integer whose digits have a sum of 1000. What is k? Okay, so first let's try to make sense of this. So that means it's 8 times 8, 8, 8, 8, 8, 8, all the way to 8. And then this is k times. Right, and let's say, yeah, and this is 8 times 8, and then 1, 1, 1, 1, 1, 1, you have this 4k times, right? And so this is 64 times 1, 1, 1, 1, 1, 1, k times. And then before we try to make it have a sum of 1000, let's just try to look for a pattern with k equals 4. Then that would be 64 times 1, 1, 1, 1, so it's 6, 4, 6, 4, 6, 4, 6, 4, right? And so these two get 1, 1, 1, and so that would make it 6. This 6 plus this 4, and then plus 1, 1, 1 from these three, and these 3 ones are all supposed to go up to like the next what do you call it, next digit, but then we're caring about the sum of the digits, so they don't really matter. We can just have them 1, 1, 1, right? And so we notice that if we have a k of some sort, then there will be always k minus 1 number of ones, and 6 and 4 will always be left over. And if you want to check, you can also try it with k equals 6. It also works if, so this is 64 times 1, 1, 1, 1, 1, 1, and so this is 6, 4, and then you have 64, 64, 64, 64, 64, 64, so that gives you 5 combinations of 6 and 4, so that is also 6, 1, 1, 1, 1, 1, 4. There's 5 ones, which is 1 less than 6, and there you have it. We know that the sum, yes, so the sum of digits equals 6 plus 4 plus a k number of ones, no, k minus 1 number of ones, so this is k minus 1, so this has to be 1000, right? And so that means 9 plus k equals 1000, so k should equal 991, so the answer is D. Number 21, positive integers a and b are such that the graphs of y equals ax plus 5 and y equals 3x plus b intersect the x-axis at the same point. What is the sum of all possible x coordinates of these points of intersection, right? Okay, so first let's try and solve for the x-intercept of these points, right? And so y, and so yeah, the x-intercept for y equals ax plus 5, that would be y has to be 0, so x equals minus 5 over a. And for y equals 3x plus b, that would be minus b over 3, because it's when y equals 0. And so since they intersect the x-axis at the same point, minus 5 over a and minus b over 3, they have to be same. Minus 5 over a equals minus b over 3, and then plus plus, that makes it the same thing. So if we cross multiply, 15 equals ab. And so and so the only restriction we have on AB is that AB are positive integers, right? And so from this, if a is 15, b is 1. If a is 5, b is 3. If a is 3, b is 5. If a is 1, b is 15. And that is all the values of a and b that we can muster, because these four, 15, 5, 3, and 1, they are the they are the factors of 15, right? And then what's the sum of all possible x coordinates? But then we can see that the x coordinates are minus 3 over b, right? So the sum of minus b over 3. And so since we have the possible b values here, we can just make it minus 3 minus all over 3, and then 1 plus 3 plus 5 plus 15, 1 plus 3 plus 5 plus 15, this equals minus and all over 3, and this would be 24 equals minus 8. So the answer is E, negative 8. Number 22, in rectangle ABCD, AB is 20 and BC is 10. Let E be a point on CD such that CBE equals 15. What is AE? So if we draw a picture, then it will be just like this, right? So ABCD, AB is 20 and BC is 10, so this would be A, B, C, D, and this would be E, the point on CD, and CBE is 15, so this would be 15, this would be 15, and this would be 90, and so this would be 30, this would be 60, right? What is AE? So we want to know this, but we know that AB is 20 and BC is 10. Okay, so what do we have? First, we notice that this triangle is a 30, 60, 90 triangle, because this is 30, this is 60, this is 90, so we can say the ratio is, if CE is A, then this would be 2A, and this would be root 3A, correct? But then since this is a isosceles triangle, both angles are 15, that means this length and this length are the same, so this length would also be 2A. So BC would be 10, so this equals 2A plus root 3A. A equals 2 plus root 3 all under 10, and so this would be 10 times 2 minus root 3. And so 20 minus 10 root 3. But then, yeah, and so now we can solve for DE, because DE, this is 20 minus A, but then A is 20 minus 10 minus 20 minus 10 root 3. So this is 20 minus 20 plus 10 root 3. So this is all basically 10 root 3. And AD equals BC, so this is 10. And since this is a right triangle, we can see that this is 1 to root 3. Therefore, this should be a same as this triangle. It will also be a 30, 60, 90 triangle. And so the ratio of the length are 1 to root 3 to 2. So this would be 2 times this much, which is 10. So that would be 20, right? And so what is AE? The length of AE is 20. The answer is E. Number 23, a rectangular piece of paper whose length is root 3 times the width has area A. The paper is divided into 3 equal sections along the opposite length, and then a dotted line is drawn from the first divider to the second divider on the opposite side as shown. The paper is then folded flat along this dotted line to create a new shape with area B. What is the ratio B to A? Okay, since the length is root 3 times the width, but then this is divided into 3, so let's say that this whole length is 3, and so this would be root 3, right, because the length is root 3 times the width. And if these were divided into 3, then then these individual sections would be 1, 1, and 1. And we can draw these lines like this, and we can see that all these triangles will become 30, 60, 90 triangles, because this is right angle and the ratio of the length is 1 to root 3. So this would be 2, and same thing for here, root 3, 2, root 3, 2, and then this would be root 3 because it's the same as this one. And yeah, let's focus on the folding part. If the paper is then folded flat along this dotted line, then that would mean, since these and these are equilateral triangles, that would mean that this part would just flop over to make something like this, right? And so this part will come over like this, and so the area of that would be this much, right? And so if we see that is so if we see this triangle is the same as this triangle, same as so if we see this triangle is the same as this triangle, right? And so that means we have 4 of these 30, 60, 90 triangles with area B. So this is 4 times triangle. And A is the rectangular piece of paper itself, which has the area A. And if we see the paper itself, it has an area of 1, 2, 3, 4, 5, 6 of the same 30, 60, 90 triangles. So this is 6 times 30, 60, 90 triangles. So what is the ratio B to A? 4. So it's 4 triangles to 6 triangles. This is obviously 2 to 3. The answer is C. Number 24. A sequence of natural numbers is constructed by listing the first 4, then skipping 1, listing the next 5, skipping 2, listing 6, skipping 3, and on the nth iteration, listing n plus 3 and skipping n. The sequence begins 1, 2, 3, 4, 6, 7, 8, 9, 10, 13. What is the 500,000th number in the sequence? So this is how the sequence begins, right? And then what we can notice is that so we can make an in list and an out list. So in would be 1, 2, 3, 4, and then 5 would be out. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and then 19, 20, 21, like that, right? And so if we think of terms of the whole thing, like both in and out, both in and out parts, then we can kind of divide this into parts of 5 and 7 and 9 and like that, right? So this would be 5, 7, 9, etc. And so the total number, so the total number of numbers in both in and out would be 5, 7, 9, all the way to like to 2n plus 3, right? And so this would be and so yeah, we can say that 5 is 1 plus 4, 7 is 2 plus 4. No. 5 is 1 plus 4, 7 is 3 plus 4, 9 is 5 plus 4, all the way to 2n plus 3 is 2n minus 1 plus 4, right? And so if we take out all the 4's, there will be n 4's, so it's 4n, and plus will be 1 plus 3 plus 5 plus all the way to 2n minus 1. And so these are n numbers and odd numbers, and we know that the sum of n odd numbers is just n squared, right? And so this much is 4n plus n squared, and so the total number of all in and out combined, that would be 4n plus n squared. And now we will say yes, and now let's look at the total number of numbers for just the in parts, right? That would be in only. So this is 4, 5, 6, all the way, right? 4, 5, 6, so up until n plus 3, right? And so this equals and next, let's look at the total number of numbers that are only in the in list, right? And so that would be the whole thing minus 5, 11, 12, 19, 20, 21, right? And so that would be in only, that would be the total of this much. So 4n plus n squared minus 1 plus 2 plus 3 all the way to n, right? So that would be n plus 1 over 2. And so this is n squared plus 4n minus n squared over 2 minus n over 2. This equals n squared over 2 plus 7n over 2, right? And so this is n squared plus 7 over n squared plus 7n all over 2. N squared plus 7n all over 2. And so this is the this is what number you're at, and so this is the nth number. No, and so by these two, what we get is that the n squared plus 7n over 2 the number is equal to 4n plus n squared. And so for this to and since we want this, we can say that 500,000, this has to be very close to n squared plus 7n over 2, and so n squared plus 7n should be close to 1 million. And so if we see this is 1,000 squared, right? And so n equals 1,000, that would be too many, and so we need a little less than 1,000. And so if n is like 993, then that would make it 993,000. And so if it's a little bigger than that, 994, that would make it, no, if it's a little bigger, like 996, right? And then that would make it 996 times 1003. 996 times 1003, that would result in, what is it? That would be 998,988, right? And so that is the closest that we can get to 1 million. And so n would be 996. N equals 996, right? And so that would give us 4n plus n squared value. And so if we put in, no, actually we need to make sure that this is the 500,000 number, because if we put 996 into here, it will produce a value that is slightly less than that. And so we need to put in 996 to n squared plus 7n over 2 again. And so if we do that, it's 996 squared, no, it's 996 times 996 plus 7, 1003, over 2. We solved this before. This was 998,988, and this over 2 equals 449. Sorry, this is 499,494, right? And so this is the 499,494th number, and for this to be the 500,000th number, we need to add how much? 506, right? So we need to add 506 to whatever it is when n equals 996. So our final answer would take the form of 4 times 996 plus 996 squared, and then we have to add this much because that's the number of numbers that for it to be the 500,000 number. So it's plus 506. So this much would be 996 times 996 plus 4, which is 1,000, plus 506. This is 996,000 plus 506, which is 996,506. That would be our answer, and we can find that in number A. So the answer is A. Last problem, problem number 25. The number 5 to the 867th power is between 2 to the 2013th power and 2 to the 2014th power. Wow. How many pairs of integers m comma n are there such that m is greater than or equal to 1 and less than or equal to 2012? And this property is holds true. And so from this, what we can see is that between consecutive powers of 5, there are 3 powers of 2. And if we just like try to list all the and if we try to list just the multiples of 2, that will be no, try to list, yeah, so that would be 2, and then 2 squared would be 4, and then 8, 16, 32, 64, 128, 128, and then what's next? 2, 6, 2, 56, 512, 1026, and so on, right? And then if we put in powers of 5, then 5 would come in here, 25 would come in here, and 125 would come in here, and 625 will come in here, right? And so we see that mostly there are two powers of 2 between consecutive powers of 5, but sometimes, like this case, there are 3. And so what we need to find is the number of cases where there are 3 powers of 2 between consecutive powers of 5. And so what we can see here is that mostly it's 2 powers of 2 between powers of 5, but then sometimes 3 powers of 2. And so we can use the information that they give us at the very start. 5 to the 867th power is between the 2013th power and 2014th power. That means 587. This is 2 2013 and 2 2014, right? And so so we don't know what comes before this, but then we know that up until the 2013th power, all of m, they are contained in here, right? And so what we need to do is 2013, which is this number, minus 867 times 2, and that will give us the answer. But why does this give us the answer? Okay, so if you look back to this thing here, we saw that for every so we saw that for every power of 5 there were 2 powers of 2, and for this one too, for this power of 5, there were 2 powers of 2, and there's 1 left over, right? And so what we're doing here is counting the numbers that are left over when we calculate the number of powers of 2's minus 2 times the number of powers of 5's, because 2 times the number of 5's, subtracting that will take away all the normal ones, but then for the special ones, they will take out 2, and then they will have 1 left over. So for each special so for each value of m that makes this true, there will be 1 value left over, right? And so this is basically taking telling us how many of these numbers are left, which is the number of pairs of integers m comma n, such that blah blah blah. All right, and so let's calculate this. This is 2013 minus 867 times 2, which is 1734. This is 279, so the answer is B. So that was the all of the problems, and thank you for watching.